So I'm going to talk to you about Killing Fibonacci, a journey of 10 lessons. So this is me, 2005. Kind of a little bit of a squinty eye, confused looking face there. In 2005, I built my first Rails app. It was Rails 0.8. We actually launched it right after 1.0 came out. I didn't know a lot about Rails. I didn't know very much about Ruby at all. And I wish at the time, I wish that 8 years ago, I had had a mentor to show me the way. So we're going to take a journey back to 2005. Danny 05 gets a visit from Dan 2013. Because who better to mentor me 8 years ago than me today? And I can see the other talk finally came out, so come on in. That's fine. You are all very welcome. We can all just sort of lament the Sox loss last night while we wait for everyone to come in. So this is going to be a talk on 10 lessons that Dan 2013 gives Danny 05. So let's paint a story first. Let's suppose that I work for, this is Danny 05. I work for Invest Corp. It's a company that does stock investments. And they have a stock picker app. And they heard about this thing called a retracement algorithm, something about the word Fibonacci, and their picker app isn't doing so well, so they want me, as a software developer, to build an algorithm to predict a stock price based on the Fibonacci sequence and using this sort of retracement thingy, okay? I'm kind of a junior developer there, but we're a startup shop, so I'm it. Here we go. So let me tell you a little bit about retracement. You don't have to know a lot about this. Retracement is the idea that if I have a large drop, or it could be a rise, and there's a rebound, the amount of rebound before the drop continues is called the retracement. And a lot of people want to predict that, because if I know when that is, that would be a great place to buy and a great place to sell, wouldn't it? There are a variety of retracement levels. First retracement, second retracement, third retracement. Lots of different ways you can calculate that. For now, and particularly for the new people, which is exciting, retracement is important to understand as it's the rebound, okay? So the front end of our story, the front end team is anxious. They have a UI prototype. They want to get going. They need that algorithm. They need that predictor. I heard about this TDD thing. I'm not sure, but I want to give it a try. So I open up my trusty editor, and I know I need a spec file, so let's make a retracement predictor spec. We're going to describe a retracement predictor class. And we need our first spec. It should, how many have been at this point before writing a test? Yeah, brand new to it. What do I do next? So lesson number 1, courage. Conquer the fear. Mike said this yesterday, don't be afraid. It is so important when you're starting out with something new, particularly testing, to conquer that fear, to enter in and step forward. Or as John Wayne said, I'm from Colorado, so I got to have a picture of a horse out here. Courage is being scared to death and saddling up anyway. So let's saddle up. But how do I really start? Well, lesson number 2, baby steps. Or no, that was the next one. Sorry, find your peace. Skipping ahead. Find your peace. Or another way, find your green. Now, I was at Rocky Mountain RubyConf a few weeks ago, and Brian Merrick gave a good talk on automatic and effortful. And in that talk, he talked about dancing the tango. And he said that when you're dancing the tango, I don't dance the tango, so I'll take his word for it. But he said when you're dancing the tango, there are moves that you're in, and there's really only one thing you can do. You're in the midst of a move. There's a feeling of tension as you move through that move into the next one. But there is a position at rest, a position at peace, where from that position you can do a bunch of different moves. It is so important as developers to know what your peace is. to know what your position at rest is, because that tension when your tests are red or you don't know or something's broken has an important effect. So find your peace, find your green. So let's find our green. I do this a lot. The first thing I'll do is the simplest thing I can do just to make sure the plumbing is working and my test is working. And it fails because I don't have my retracement predictor class, but that's easy enough to fix. We'll just put that right in. And now I'm green, okay? I have found my peace. It's a very simple start, but big things happen from small beginnings. A tip that I find is do a quick check to red. Gary Bernhardt, who does the Destroy All Software screencast, does this all the time, and I love it. When your tests are green, take a quick moment to just flip something and know that it fails, because even worse than a red test that should be green is a green test that should be red. So let's flip that to 0. It fails like we expected, and we'll flip it back. Good, we're green. Okay, so how fast, how slow? Do I write lots of tests? Do I write lots of code? Lesson 3, baby steps. Okay, do the minimum valuable test. Don't bite off more than you can chew. Start with something very simple to get you going. In other words, grab a happy path. So let's do that. We're building a retracement predictor. It should return the first retracement for a starting value of, let's just keep it simple, for a starting value of 0. So we will drive out a predictor class. We want a predictor object that can have a method predict retracement. When I pass in 0, it should be 0. Our test fail. So now we need to drive that out. Okay, I'm missing some plumbing here, so let's create the predictor instance first. And you can see now it tells us we need a method retracement on it. So we'll define the predict retracement, passing in the input, and what should go here. So I've got a little bit of momentum, but I'm not sure what should go next. Some Fibonacci thing, right? We saw that earlier. I know I need to do a retracement thing with a Fibonacci function. So another tip I do when I'm in a position like this is a quick check to green. If I'm in the middle of a test that I'm driving out some code and it's broken, but I just want to see that green because I want that piece. So I don't know what my algorithm is here, but I know that my test wants it to be 0, okay? I'm green again. Now I'm not done by any means. I have not implemented Fibonacci here. So let's start building Fibonacci, come on. I want my retracement predictor to calculate Fibonacci. So it's going to return a calculation of that. That's an implementation detail. So I'm going to drive that out as a private method. I don't need it to be part of the API. So I'm going to take some value through the retracement predictor and calculate Fibonacci. And we're green. But now grab another happy path. We're definitely not done. All right, so we've done, for a starting value of 0, we've calculated fib of 0 is 0. Let's start by just putting the Fibonacci sequence up. I mean, I don't know how many have it memorized. I certainly don't. So you can see like fib of 0 is 0, fib of 1 is 1, 2 is 1, it goes like that. I'm going to create another test for another happy path. The first retracement for a starting value of 1 should be 1, right? Well, our tests fail. Our production code is not correct. So what should I do here? I don't know. How about value? Our test pass. So I'm rocking now. I've got some momentum. I got a couple tests. Things are looking good. Can't I just keep going now? I know I need the fib algorithm. Can't I just code it or paste some code in? Lesson number 4, stay focused. Stay focused. You need to find your rhythm as you're developing. And what's interesting to me is my rhythm may not be your rhythm, okay? Understand that. But also understand your own tension versus peace. Understand that the feeling of when everything is going well, there is a physiological feeling of success with that. And know that when something's broken in that tension, how can I get back to a place of peace quickly? Minimize the red time. Ben Orenstein, the ThoughtBot, did a play-by-play, and this is big for him. He says he will take small steps in refactorings even when he can see the end game because he wants to minimize the red time. I think that's important. And lastly, don't stop the tests. So let's keep going. We know that's not how you calculate Fibonacci. So let's drive another spec. Okay, for a starting value of 2, what should it be? Fib of 2, we look up there, is 1. So we run our tests, and the tests fail. So our code is wrong. Well, what if we do something like this? What if we just say value is, if it's 0, return 0. If it's 1, otherwise return 1, and our tests are green. But that's not good enough, so let's do another one. Let's write another test. For a starting value of 3, the predictor should return what? 2. So fib of 3 is 2, and our tests fail. So I don't know, how could we do that? Well, I don't know, what if we do this? What if we say if value is greater than 1, let's do value minus 1, otherwise do value. Hey, and our tests are green. But I'm still not sure about this, so let's do another test. So for a starting value of 4, what should fib of 4 be? Well, fib of 4 is 3. Hey, our tests are green. Maybe we're done. Maybe this is Fibonacci. Do we implement Fibonacci? I don't know. Just to be safe, let's do one more. So for a starting value of 5, what's fib of 5? Fib of 5 is 5. And we run the tests. Oh, they're broken. All right. Well, from 2 to 4, it's value minus 1. Otherwise, it's value. And we're green. Yay. All right. But something doesn't feel right. Are my tests telling me something? It's funny and we laugh, but something's wrong there. So lesson number 5, listen to your tests. And by listen to your tests, I mean Sandy Metz said this yesterday in the interview with Matt. She said, when I'm green, I take that step back and I look at my tests. I look for refactorings, but I also look for patterns. Listening to your tests mean introspecting on what you're doing and how you're doing it, how the shape works. I tried this as an experiment. I took some of my tests and I passed it through a ROT13 converter, so I was not distracted by the English, and I just looked at the visual shape of them. Sometimes that's useful. I gave a lightning talk 2 nights ago about drawing up your tests. Sometimes just seeing the physical shape of them can help you do that. So let's look. What do we see here? Well, that to me looks really repetitive. There is a pattern there. So we're green, even though we haven't implemented Fibonacci. Let's roll this up. Let's roll this up via hash iterator. And I went ahead and added all the way through 10. So given an input, I should expect a certain output for the retracement predictor. And now, because I'm rolling this up like this, I can go and I can delete all of this repetitive code. And I've also added 5 more tests. So we run the tests. The first 6 still pass, but the rest fail. We have not implemented Fibonacci. What could we do? I know. A case statement. And we're green. Says Danny05. I don't understand this. How can I design what I don't understand? This doesn't feel like we're heading in the right direction. Lesson number 6, know your domain. It's really good to get started, and oftentimes getting started is what you need, even in a simple case like this, but you have to know your domain. So maybe we're not approaching this correctly. We're getting too caught up in the weeds of Fibonacci. What is it we really want to do here? But first, let's just finish off Fibonacci here. So we don't want a case statement. We're going to go ahead and use, we'll add 10 more tests, so we do fib all the way through 20. We're going to do the recursion method of implementing Fibonacci, which is fib of a number is the sum of the fib of the previous two numbers. So we're failing with those extra 20 tests because our case statement would have to be huge. We'll go ahead and do return of the fib of the previous two, and now we're green, okay? So now we can take that step back. So wait, like, can I do this? Can I restructure everything? I don't really want a Fibonacci thingy. I want a stock price predictor, right? Lesson number 7, refactor from green. If you know that what I want to build is different than what I have, so I need to refactor it, but I'm not green, how will I know that I've succeeded in my refactoring? Okay? The state of peace, of at rest when you are green is important as you step out into the red to make changes, small or large. So start from green. But my tests just look like they're vetting the code. Is that okay? Can I do that? Lesson number 8, behavior, not implementation. We hear about this a lot, right? The point of TDDing is to help discover what it is you're building. It's exploratory, it's discovery. Yes, of course, it's also validation, it's correctness, it's regression, it has a lot of other value. But fundamentally, the reason that I TDD now is so that I can explore what I'm building. The domain here is really stock prediction. Retracement is a technical term. And Fibonacci is an implementation detail. Why are we thinking about these things? The UI team won't even care about them. So let's make a stock price predictor. I don't want a retracement predictor. I want a stock price predictor. Start with refactoring to a pure Fibonacci calculator. Okay, so I'm going to take what we had done as a retracement predictor, which is really just a Fibonacci calculator, and let's make it a Fibonacci calculator. And I can do this because I'm green. So I have confidence that I can go and change my code the way I want to. And the structure of it is actually already set up quite nicely to be a Fibonacci calculator. You can see that I just need to change some naming around, change the retracement predictor to a Fibonacci calculator. Clear out that method. I don't want that method. I just want a public method of calculate. Clean up the line break, and we're green. Okay? I now have a simple Fibonacci calculator here that I can use. So Danny 05 says, this seems like a lot of work for very little code. Will I still get my production code done in time if I TDD it? How many people have had this very question? I want to be rigorous in my TDDing, but will I get it done in time? Lesson number 9, tenacity, stick-to-itness. This is an important thing as developers because we will always be under constraints. There will never be enough time to do what you need to do the way you'd ideally like to do it. But you have to stick with it. Because TDDing is slower than cowboy coding, or what I like to call TLMD, test later maybe development, unless you care about such things as these. Quality, expandability, refactorability, longevity, understandability, documentability, team members, future developers, including your future self, bug detection, coding fiercely. Now these are my opinions. Certainly, I don't want to dictate this is how you must do it, but I found the rigor of TDD helps me in all of these, and I would imagine it would help you as well. Mastering the art and rhythm of TDD requires tenacity. It is important to understand this. This was my huge epiphany a few years ago. TDD is not something you get for free. As a Rubyist, you are not a TDDer. You are not a tester. It is a skill, a discipline, like anything else. You have to master it. You have to practice it. Or like Sandy Metz said yesterday, she thought TDD was a cruel joke played upon her by smart people. But she persisted because she trusted those people. And in the end, she got better at it. All right, so we want a stock price predictor. We have our Fibonacci calculator. Let's drive out our stock price predictor. So we wanted, what should it do? How do we get started? Well, we need a stock price predictor class. Start small, keep green. We're green. And here we go. What should it do? Well, let's put a little plumbing in place first. I know I'm going to want a stock price predictor object. And I know I want it to have a starting price, or a starting value and ending value. Actually, I do want it to be a starting price and an ending price, and a starting point. And when I have that, then I can call some method on it called the first retracement, and it will return for me the first retracement value of that stock price. So I don't know what that's going to be. Let's set it to a variable for the moment, because I need to put a little bit more plumbing in place here. So I don't have my starting price, ending price, or starting point. And you notice I switched up syntax here. You can do that. It's Ruby. No problem at all. So I set the starting price to 2, super simple, ending price of 1, and a starting point of 1. Very easy, happy path. And then my retracement value, what should this be? I don't know, okay? I'm now trying to drive out this algorithm a little bit further. I'm going to put 0 in now, because I think if I run the test with question marks there, it would probably break. I haven't actually tried that. But now I know what I need. Oh, I don't have my method, or I don't have my instance initialize method. So let's initialize the class. Give it the starting price, the ending price, the starting point. We'll set those as instance variables. And then we run the test, and we need to create the first retracement method. So let's drive that out. And this is where the algorithm would go. This is where that algorithm for how you calculate retracement. Well, the algorithm is very simple. Starting price minus ending price times the starting point divided by the fib of the starting point. Okay? And the higher the starting point, the better the predictor. So let's write that algorithm. And you can see if I have a starting price of 2, ending price of 1, so that's 2 minus 1, times 1 divided by fib of 1. I'm getting ahead of mine. So I plug in my Fibonacci calculator. That should equal 1. And it does. Okay? So my algorithm is doing the right thing. Let's just quickly check it to see if I had a starting price, let's say, of 10, keep it fairly simple, ending price of 8. So 10 minus 8 is 2. Starting point of 2, so I got 2 times 2 is 4, divided by fib of 2, which is 1, should give a retracement value of 4. So I've fleshed out the stock price predictor a little bit here. Now what I want to do is inject the calculator, just for cleanup's sake, because right now my stock price predictor has Fibonacci calculator as an internal dependency, and I want to pass it as an external dependency. So you can see I just need to add a calculator as a parameter there. And now I can pass it in, which might make it nice. I might want to mock it later, or set up a test double for it, something like that. It makes it a little easier this way. And now I'm green. So I have a really simple stock price predictor that is delegating to my Fibonacci calculator and running that algorithm. But Danny 05 says, okay, but still, this whole TD thing seems like a waste of time. Why do it? Lesson number 10. This is the final lesson for today. Don't write code. Create software. You aren't paid to write code. You are paid to build software. Coding should be craftsmanship. Or as Matt said yesterday, our job is not to write code, but to build things, to materialize ideas. This is so important when you remember that. So once more to the code, I'm going to skip a variety of iterations, and we're going to look at it in its completed form. So this is the spec for Fibonacci calculator. I just added a few more things to clean it up. I can pass in a method, because it turns out there's 4 methods. I added a little check there, so it'll throw an error if I don't have a method. It'll verify that the default method is used. I added fib through 20 variances. And then I'm checking the 4 methods. There's recursion, iteration, array, and matrix. are the 4 common methods for calculating Fibonacci. And I check that each of the 20 values work, as well as if I call the sequence, it should return it. And you can see the 4 methods there. And then just for fun, I added a couple of tests just for this presentation. I want to run through the 4 methods on fib of 30 and just see how long it takes. So I'll do that and then output. I also then want to run fib of 250,000 on the 3 that are faster and see how long it takes, because the recursion method is really slow. And then I want to run fib of 1,000,000 on the matrix method. And I want to output how big it is, but I can't output the number. The number is so huge, I can only output the number of digits. So this is running. You can say it takes a couple seconds to run. I'll expand the window here so we can see it. So the 4 fib methods, you can see the recursion took about a little more than half a second. The other 3 took hardly any time at all. When I take the recursion method out and run fib of 250,000, each of the iteration took about 2 seconds, the array method took about 5, and the matrix took about a little less than 1 second. If I run the matrix method against fib of 1,000,000, it took half a second, and the answer to fib of 1,000,000 is a number that has 86,784 digits. So who says Ruby isn't fast? So this is the Fibonacci sequence, the Fibonacci calculator implemented. Very simple code. I pass in a method, raise an error if it's unknown, and then I delegate the calculate 2 private methods that implement the 4 different versions: the recursion, the iteration, the array, and the matrix. So very simple code. Let's look at our stock price predictor. So we had started it. This is the spec for it. I've upped my numbers. You can see that I'm using the Fibonacci calculator. I'm using 140 in 7 iterations. I now call them iterations because I realized it's not a starting point. It's iterations, how many times through. I pass a variable whether I want to use floats or not. And then I have just this pattern emerged as I was TDDing this. So I can do a first retracement level, a second retracement level, or a third retracement level. And so I have 4 contexts, 1 to test the float, and then 3 to test it via integer. And this is just what I should expect when I run it with the third retracement level. And the numbers get different, and we'll see a little bit more about that in a second. But all my tests are green. They run really fast. So this is the stock price predictor class. I did have to require a standard deviation. Found a library online that just had some 4 simple methods so I could calculate the mean, standard deviation, because I wanted my information for that rebound to be accurate. I pass in the calculator, the starting price, the ending price, retracement level that I want, and the number of iterations. Set all those as instance variables, and then it's just a very simple API. There's 3 API calls: rebound, predicted price, and deviation. So rebound is the height. Predicted price is just that height applied to your starting point. And then the deviation is, if I run it over multiple iterations, what is the standard deviation? The method actually is high minus low divided by fib of y over fib of x. So actually, I was wrong about the algorithm at first. And TDDing this helped me explore that. So this is just the code for doing that. Not super interesting, but it does work. This is a little bit of train coding I did. For those that heard Brian Lyles, he talked about train coding. It's a simple little script, but I wanted to see this really work, okay? So it's a script. This just takes an input of a high, a low, a number of iterations, whether I want to use floats or not. And then it just runs through the first, the second, the third retracement, and then averages the first and the second. So let's watch this run. So I'm going to do just like the test. I'm going to put in 140, iteration count of 7, and you can see the numbers that it runs there with a first and second retracement average of 71, plus or minus 6. That's our deviation. Let's run it again. We'll do the same thing, but we'll do it with float, just so we can see how the numbers now can be calculated via float. And we did 20 iterations, so our deviation is smaller. The more iterations we do, the closer we get. Well, I want to run it another time, and I don't know, let's pick a stock price of 463 as a high, 390 as a low. We'll do 10 iterations, see what it says. So if the first and second is 426, remember that number for a moment, 426. We'll come back to that. Let's do it one more time. I don't know, how about a high price of 507, low price of 396, iteration count. We'll do 10 again. So you can see the numbers I get. The average of first and second is 452. Remember that number. 426, 452, okay? Huh, anybody know this stock ticker? This is Apple, the last 6 months. You can see a low of 390, 463, and a retracement rebound at 428. Low of 396, high of 507, retracement at 450. What did we end up with? I think it was 426 and 452. Huh, there's something to this. So let's review our 10 lessons here. The most important lesson that if you remember one of these 10 is number 1, courage. Conquer your fear. When you're faced with something new, don't step away from it, step into it. Number 2, find your peace. Find that place of rest, find your green, as I said earlier. Number 3, take baby steps. Particularly when you're learning something new, take baby steps. Small victories move you towards large victories. Number 4, stay focused. Keep your eye on the ball. Number 5, listen to your tests. Take that moment to step away when your tests are green and look at them. Introspect. Number 6, know your domain. It's really hard to do anything well if you don't know what it is that you're trying to do. Number 7, refactor from green. Make sure that you're at rest before you move into another step that will take you into some tension. Number 8, behavior, not implementation. Let TDD be exploratory. Let it help you understand what it is that you want to build. Number 9, tenacity. Stick-to-itness. It's really important. I don't know if you guys have ever seen the picture. My dad gave me this picture when I was young. It's the one of the stork that's eating the frog, and the frog has got its arms around its neck while it's in the stork's mouth. And the caption is never give up. If you Google for never give up in images, you'll find that. And number 10, don't write code, create software. Or as Dale Carnegie said, I like this quote, if you want to conquer fear, do not sit at home and think about it. Go out and get busy. Thank you.